Let's learn about nets of rectangles and cylinders. Let's think about nets in terms of everyday items. First of all, I want you to look at this box. And a lot of times when you need to mail presents or gifts or packages or just return something in the mail, you have to go to the store and buy a box. So this box doesn't really look like much. It's just a flattened version of a box. Now, when we put it together with our packing tape, this box goes from being two-dimensional to three-dimensional. So what we can really say that a net, a geometric net, is very similar to this picture of the box in 2D before it's been assembled. A geometric net is a flat two-dimensional representation of a three-dimensional figure. And I want you to think about why we're learning this. When we break down a three-dimensional object, for example, this is a rectangular prism, when we break this down and we lay it out into its net, or it's the flattened version of itself, we can actually help to understand how the surface area of that rectangle is calculated. Because the surface area of that rectangle is just going to be the area of each one of the rectangles in the net added together. So the surface area is going to be the sum of the areas of the 6 individual rectangles. And what's really important about a rectangular prism is that it has to have a net that has 6 sides. 1, 2, 3, 4, 5, and 6. What features must a net have in order to be a rectangular prism? Well, we already know that a net of a rectangular prism has to have 6 faces. And faces is just a math word for sides. So 6 faces or 6 sides. And all of those sides have to be connected. So they all have to be in one, really in one piece. And then the second characteristic would be that all 6 faces are either rectangles or squares. Are either rectangles or squares. And remember that special 3D figure that has 6, the faces are all squares? What do we call that? That's right, we call that a cube. All right, working with our net, let's see if we can calculate the surface area and volume. Now, this is going to be the first example on your nets of 3D figures notes. So first of all, we want to confirm that the net that we're given is actually a real rectangular prism. We can do that by counting the number of faces or sides of the net. 1, 2, 3, 4, 5, 6. So I have 6 faces, and those faces are all connected. So I know I have a correct net for a rectangular prism. And over here, what I tried to do is just draw a rectangular prism and then bring in the different colors of these sides from the net to the cube or to the rectangular prism once we build it up. So you can see that the 2 yellow sides are congruent, and so this yellow side would be the bottom and this yellow side would be the top. So you can see the yellows at the top and the bottom. These 2 blue sides, okay, these could be the front and the back of our rectangular prism. Again, the 2 blue sides are congruent. Finally, we have 2 green sides. Those green sides are congruent, and I'm going to call those my ends. So I'm going to have one end here and then another end over here, which we can't see. So before we get started, let's go ahead and write down what the variables are from our net. So our variables, our dimensions are going to be length is equal to 5, width is equal to 3.2, and height is equal to 4.2. Now, it doesn't matter which order you write these in. You might write them differently. You might write the length is 3.2, the width is 4.2, and the height is 5. And that's okay because we're going to get the same answer at the end. So let's go ahead and plug these into our formula for the surface area. Surface area is going to equal 2 times length times width. So remember, our length is going to be 5 and our width is going to be 3.2. So that's going to be 2, whoops, let me go back, 2 times the product of 5 times 3.2. Okay, then we're going to add 2 times the product of length times height. Length times height. So that's going to be 5 times 4.2. And then the last one is going to be 2 times width times height, which is going to be 3.2 times 4.2. Once we add all of these together, we're going to get a total of 100.9 square centimeters. Okay, so all I did was I took the sum of this piece, which is 2 times the product of 5 times 3.2, and that gave me 32. Now I'm going to took this 2 times the product of 5 times 4.2, and that's going to be 42. And then on this very last one, I took 2 times the product of 3.2 times 4.2, and that's where I got my decimal, and that was 26.9. So when I add up all of these numbers, the 32, the 42, and the 26.9, I got 100.9 square centimeters. Remember that our unit of measurement has to be in terms of square units. So the volume is a lot easier to calculate because the volume is just a string of multiplication problems. It's just one big multiplication problem. So let's write down what the volume is. The volume formula is going to be length times width times height. Length times width times height. Let me put some little multiplication signs in there for us. Okay, so I'm just going to substitute in the same numbers that I used in my surface area formula down into my volume. So my length is going to be 5. Okay, my width is going to be 3.2, so I'm going to put that right here. Whoops. 3.2. Whoops. And my height is going to be 4.2. So I'm going to multiply times 4.2. Now when I multiply that all together, I ran out of space, but I did get 67.2 cubic centimeters. It's important that your unit of measurement has the exponent of 3. So again, for volume, all I have to do on a rectangular prism is just multiply all of the attributes together. Length, width, and height. 5 times 3.2 times 4.2. When I multiplied that all together, I got 67.2. Now, if you want to try to estimate this in your head, what you could do is you could say, okay, 5 times 3 is 15. And then 15 times 4 is 60. So I got 67.2. So I found out that my answer is reasonable. All right, can you identify the net of a rectangular prism? Remember that the most important characteristic is the net of a rectangular prism has 6 sides. So if we wanted to draw the net of a rectangular prism, we're going to be looking for that net to have 6 sides, and all of the sides are attached to each other or connected to each other. Now, what if we had something that looked like this? We had So we had a rectangular prism, or we're asked to figure out, is this a rectangular prism? The first thing I would do is I would count the number of faces or the number of sides that the net has. And maybe that will help me determine if it is or is not the net of a rectangular prism. So let's go ahead and count. We have 1, 2, 3, 4, and 5. So this is not the net of a rectangular prism because this net only has 5 sides. The net of a rectangular prism has to have 6 sides. A good way to visualize the net of a cylinder is by looking at this can of soup. You notice that the can is a cylinder. It has 2 circular bases, so it has a base up here, which is a circle, and then has a base down here that you really can't see because the can is sitting on this base. And then it has this lateral piece, and we call this piece that goes across, we're going to call that our rectangle. So a cylinder can really be broken down into 2 pieces, circles and 1 rectangle. So if we were to peel off the Campbell's soup label and lay it flat next to the can, it would look something like this. Your label would look something like this. Okay? It's just going to come off, it's just going to look like a plain old rectangle. Now, that is only one piece of the cylinder. That is just this side, or the label, okay? But remember I said that a soup can has a top and a bottom? Well, in order to show on our net or top or bottom, we need to know that the tops and bottoms of my soup can are circles. So I'm going to add 2 circles, one on this side and one on this side. And that would be a net of a cylinder. Remember, when you have a net of a cylinder, you're going to be drawing a rectangle, which stands for the lateral face or the label. And then you're going to be drawing 2 circles on opposite sides of the label. This is going to be the top of the can, and this is going to be the bottom of the can. Using this net of a cylinder, let's calculate the surface area and volume. So let's go ahead and write out our surface area formula. Surface area equals 2 pi r squared h plus 2 pi RH. So based on our net, we see that our radius is 10 centimeters. So that number is good to go right into our formula. And then we see a height of 30 centimeters, so that number is ready to go into the formula. So let's go ahead and do our substitution. We have 2 times pi, which is 3.14. Remember, we're just going to use the numbers 3.14 for pi. We're not going to use the calculator key of pi because that's going to give us too many decimal points. And then the radius squared is just going to be 10 to the second power, which we know is 100. We're going to add to that 2 times the product of 3.14. The radius is 10 and the height is 30. So again, I like to do these in chunks. So I like to calculate the surface area of the bases first and then the surface area of the lateral side. So when we multiply the 2 times 3.14 times 10 to the square, 10 squared, that's going to give us 628. And then the next one, which is 2 times 3.14 times 10 times 30, that's going to give us 1,884. When we add those two together, we get our total surface area of 2,512 square centimeters. Okay, so now outline that. Volume is a lot easier because volume is just a long multiplication problem. So volume is going to equal pi r squared h. Pi r squared h. Volume is going to equal 3.14 times the radius squared, which is 10 to the second, times the height, which is 30. When I multiply all of these together, the 3.14, get my arrow here, the 3.14, the 10 to the second power, and the 30, I'm going to get a product of 9,420 cubic centimeters. And remember, when we're solving for volume, our unit of measure is always going to be cubic or have an exponent of 3. So lastly, you're going to need to know how to identify the net of a cylinder, or how to identify the correct net of a cylinder. So let's just draw a cylinder real quick, and then we'll get started on that. So when we took our label off the soup can, remember that I said that label, when you flatten it out, which is the same thing as making a net, is going to be a rectangle. So if you went home tonight and you took a can and then you took the label off, so in other words, you cut the label very neatly down the seam of the can, you would end up with a label that looks like a rectangle. Now, that is the lateral side or label, okay, and that happens to be a rectangle. But we have those two circular bases, the top and bottom of the can are circular bases. So we're going to have to draw our circles on opposite sides of our rectangle. So the accurate picture of a net for a cylinder would always be some sort of rectangle, some size of rectangle, with the two circular bases on opposite sides of the rectangle. It could also look like this. You could have the rectangle and you could have the circular bases on this side. And that would be okay. That would be an accurate drawing of a cylinder net. So would this one. But let's draw one that would be wrong. So how about this one? What if I had a rectangle and then I put my two circular bases right here? Well, that would be wrong because remember, our circular bases have to be on opposite sides of the rectangle. So this is wrong because our two circular bases are on the same side. As long as the circular bases are on opposite sides of the rectangle, then you do have a net of a cylinder. Thanks for watching.